Alright, as we look at our do now today, again, this is really just some review of getting some of our basic shapes going. For our basic shapes, when we look at this, our basic shape here is a rectangle, so area is equal to base times height. Thinking about quality of work, we should be starting with the equation. This is going to be 3 times 5, which is equal to 15. Here we have the area of a triangle, so we should be starting with the equation. Area is equal to 1/2 of base times height, which is equal to half of 5 times 10, or half of 50, which is equal to 25. And finally, looking at the other two, we have what is the area of this figure. This figure is a circle, so area is equal to it is a full circle, so it's not half of pi times r squared. Area is equal to pi r squared. However, we do see that we have the diameter given to us, not the radius, so the diameter is equal to 6. That means the radius is equal to 3. Pi times 3 squared, which is equal to 9 pi. That's answer choice D. And finally, what is the area of this figure below? We can see here that this is a quarter circle, so it's pi r squared would be the full circle, so we're looking for 1/4 of the circle. That's going to be 1/4 of pi times 10 squared, or 1/4 of 100 pi, which would be equal to 25 pi. Alright, looking at today's aim, Kipsters will be able to find the area of irregular figures. And we're going to do this by decomposing or composing the figure. So decomposing, thinking about bringing it apart, composing, putting it together. So when we look at this particular problem, we're going to see that really this is going to be a lot of practice from yesterday. So it's going to require a little bit of thought. And when we're thinking about these problems, the thing that I always want you to think about, and again, I want us to be thinking about the quality of our work today. How well organized is our work? I still felt like I saw plenty of people who were successful in correctly answering the alone time yesterday, but were not successful in having high quality work. High quality work means that there's work that I can follow your entire thought process from the beginning to the end. So go ahead and work on this problem with your team. Make sure that you've come to a correct answer. Use your notes from yesterday as an example of what the work should look like. If your notes from yesterday were not complete, please find somebody within your team who did have complete notes to identify what high quality work would look like. Once you've completed the problem, go ahead and come back and watch the video to check your work, and also check to make sure that you have all of the pieces of a high quality response. So if we're looking at a high quality response, the start of your logic and your understanding in this particular problem is writing an equation that represents kind of the story of this problem. So the story of this problem is that our area is going to be equal to, we started with the area of an entire square. So I'm going to say the area of a square, and we subtracted away the area of this missing piece, which is a semicircle. So this is the area of a semicircle. This is the story of the problem, and this is the beginning of showing your thought process. If you don't have an equation like this, or at least an expression like this that shows me the story of this problem, then you don't have high quality work. So the next part of showing high quality work would be showing me how you figure out what the area of those particular things are. That means in some form or fashion putting in the equation. You can put the equation immediately into this expression by writing it beneath, or you can come down somewhere else and clearly write out that the area of that square is going to be equal to base times height. This particular case, because it's a square, we know the base and height are equal to 24. And so the area of our square is 24 times 24. And our solution here would be that the area of the square that we started with is 576. So I fill this in. It should be very clear to me. I should be able to follow on your paper that where this 576 came from using this equation and plugging in these numbers in order to find the 576. If you have random multiplications and subtractions strewn throughout the page and nothing is labeled, then your work is not high quality and is not able to be followed. Part of the important piece of this is being able to go back and check your work when you have the answer wrong. I find that when I come in, I check in on some of your work and you have a wrong answer. When your work is not high quality, I cannot go through and find where you went wrong and give you a good explanation, which means that in most cases you can't do the same thing for yourself. We also need to know the area of the semicircle. I use the equation of half of a circle, pi times r squared. I'm going to plug in 3.14 for pi. 3.14 for pi, and my radius is not 24. The entire side here would be 24, so my diameter is equal to 24 and my radius is equal to 12. So this is going to be half of 3.14 times 144, which would be equal to 226.08. Coming up here, I know that is taken away from, because that's part of my story, is that it's removed space. 226.08 is taken away from the 576. So my area would be equal to the subtraction of that, which is 576 minus 226.08 is equal to 349.92. And my units, centimeters squared. Alright, so again, thinking through the steps here, what does high quality work look like? It starts with having an equation that tells me the story of this particular problem. What do I start with? What do I add? What do I subtract in terms of areas? And then something that clearly shows me how all of the individual pieces of area that are either added or subtracted are found. That is high quality work. That is something that I can follow and understand where your work came from. Alright, so go ahead and complete this problem with your teammates. Again, starting with your high quality work would be giving me the story and then finding the values. So when we look at this problem and we want to write the story for this problem, we need to think about how we can figure this particular one out. So some people may jump to say, hey, this is a large rectangle with two pieces taken out. If that's something that I do, that means I have to be able to figure out the base and height of each of these individual pieces that were taken out. In this particular case, I see that seems like a little bit more difficult task than I really want to take on, And so I'm actually going to tell the story of this problem as being a shape that was broken into 3 different pieces. We'll call this area 1, this one area 2, and this one is area 3. When I do that, now my story becomes that I started with area 1, and then I added onto it area 2, then I added onto it area 3. When I write the story this way, now I find the area of all 3 pieces, and each of them is a rectangle, so I'll be using base times height for each of them. So for area 1, I can see the base and height of that long, tall rectangle would be 9 times 3, which would be 27. Base times height would be 3 times 2, which would be 6. And area 3 would be 3 times 3, which is 9. So putting those in, this would be 27 plus 6 plus 9. Those are my 3 areas that I found the value of, which would give me a total of 42 meters squared. Alright, let's look at the problems on the back side. Alright, as you start this problem, I want to draw your attention that this is asking you to find the area of the unshaded rectangular region. So we're actually finding the area of this space and here. There are a couple of ways you can actually go about doing this. Again, I want you to go through and show your work, and I need you to find the area of this unshaded region, or this region that I have cross-hatched in red. Go ahead and make sure that your work is high quality work, that I get the full story at the beginning, and that your work is gone throughout. So when I look at this particular problem, I can see that one way it seems like I would be able to figure that out is if I knew the base and height of that particular shape. However, what I can see is that nothing down there is labeled, and so the story that I'm going to tell for this particular problem was that once upon a time I had this whole enormous rectangle shaded. I had that whole enormous rectangle shaded. So my area started as the area of a shaded region and became something after area 1, 2, 3, and 4 were all taken away. So minus area 1, minus area 2, minus area 3, and minus area 4. Alright, so in order to do it this way, I would need to find the area of all pieces, starting with the area that was originally shaded. So the base of this would be 12, and the height would be 14. When I multiply that together, that gives me base times height is 168. So the area of all of my other individual pieces, area 1 is a rectangle, clearly labeled. Base times height is 3 times 9. That's 27. Area 2, also a rectangle, that is clearly labeled, is base times height, and the base is 3, the height is 11. It's going to give me 33. Looking at this one, area 3 is also a rectangle, so base times height, and that's 9 times 5. That's going to give me 45. And area 4, also a rectangle, base times height, and the base and height are 9 and 3, so it has an area of 27. So I started with an area of my original shaded region was 168, so I come back and plug that into my story. 168 minus 27 minus 33 minus 45 minus 27. As I go through and I do all of those subtractions, I'm going to get that my value is 36 square centimeters. Alright, and finally coming over to our last problem, we have this particular shape. So this one is a slightly more complicated story than any one we've put together, so make sure that you and your team have a really clear discussion about how we could come about ending up with this particular shape before you get started. If your team is struggling in order to figure out what the story of this is, I'll give you some help here and get you started. The area of this shape, so for me I look at this as I had a semicircle. We'll call this area 1, and then from that semicircle I took away this semicircle, area 2, but then I added on this semicircle, area 3. So my story here is that I had area 1, which was a semicircle. I subtracted away area 2, that small semicircle, and then I added on area 3 after that, which was this other semicircle. Alright, so if you had trouble getting the story going, or your story that you wrote was incorrect, please go ahead and pause the video now and fix or finish your work. So the answer asks us to provide our answer in terms of pi, so as I go through and find out area 1 is half of a circle, pi times radius squared. Now the entire length of this diameter is 18, which means the radius is going to be 9. So this is half of pi times 9 squared, which is going to be half of 81 pi. So this is going to be 40.5 pi. Area 2 is this small semicircle, so it's also going to be using half of pi times r squared. In this case we see that the diameter of the small semicircle is 6, which means the radius is 3, so half of pi times 3 squared is going to be equal to half of 9 pi, or 4.5 pi. And finally, area 3 is a semicircle, so 1/2 of pi times radius squared. The radius here, we can see the diameter is labeled as 12, so the radius is 6. So this is half of 36 pi, which is equal to 18 pi. So I'm going to come through up here and I'm going to fill in my pieces. I have 40.5 pi minus the small piece that was taken away, 4.5 pi, plus that extra semicircle that was added on at the end, which I will call, or which had a value of 18 pi. 48.5 pi minus the 4.5 pi is 36 pi plus 18 pi, which is equal to 54 pi. Alright, as you move over to your alone time and you finish your alone time, notice on the alone time there's a couple of names of modules listed off to the bottom right hand side. That's one thing that you could be doing with your time. You'll also notice that when you log into your Chromebooks that there are a couple of applications added at the bottom. One of them is called Block Party and one of them is called Triplex. Both of these are kind of games of sorts that help increase your spatial reasoning or your ability to kind of put together and take apart pieces of two-dimensional and three-dimensional shapes. These are both things that I think would actually be really good for you in terms of thinking about maybe what we're doing for the rest of this unit. And so those are, whether you're working on the modules or you're working on and playing through those two games, those are both things that you could be doing. Alright, please move on to your alone time and make sure that you have your work done.